Good day to you all. Welcome to the official YouTube channel of Lightway Research and Technology Center. In this video, I will show you how to conduct multicollinearity test in Eviews. But before I proceed, please, if you are just coming across our video for the first time, kindly subscribe to our channel by clicking on the subscribe button below and turn on the notification bell so that you can be notified when we drop a new video. Now let's get started. Here in this video, we are going to cover these subtopics. 1. What is multicollinearity? 2. How to check multicollinearity problem in Eviews. And 3. Strategies to address multicollinearity problem. Multicollinearity is one of the key assumptions of the classical regression model. And this particular assumption states that the independent variables in the model should not be highly correlated with each other. So when this assumption fails, we declare that there is a problem of multicollinearity in the model. In other words, multicollinearity occurs when two or more independent variables in the model are correlated. There are 3 ways to check for the problem of multicollinearity in Eviews. The first one is the correlation matrix. Second is the variance inflation factor. And the third is R-squared. For the correlation matrix, we declare that there is a problem of multicollinearity when the correlation coefficients exceed 0.8. And this is according to Kim 2019 as well as Benjamin and others 2023. So when you are running your multicollinearity test and you are looking for studies to back up this particular rule of thumb, which is 0.8, you can cite these studies. Of course, you can also check Google for other relevant studies. For the variance inflation factor, we say there is a problem of multicollinearity when the VIF values exceed 10. And this particular rule of thumb can also be supported by this study. And for the third one, which is R-squared, we say there is a problem of perfect multicollinearity when R-squared is equals to 1. When R-squared is equals to 1. In fact, when you notice that your R-squared is very close to 1, like 0.99, 0.98, you should begin to suspect problem of multicollinearity. Now, what are the strategies or what are those things that you can do to address multicollinearity problem in any model? The first is to fold your hands. That is, you can decide to do nothing and just proceed with your analysis. But in this case, your results may not be valid for policy formulation. So I will always advise you to address problem of multicollinearity whenever you come across it. The second strategy is to transform the variable. For instance, if you have GDP, that is gross domestic products, and population as your independent variables, you can transform these 2 variables to GDP per capita. And how can you do that? Is just by dividing GDP divided by what? By population. GDP divided by population will give you GDP per capita. The third strategy is to increase the sample size. When you increase the sample size, the standard error of your regression coefficient will reduce, and the adverse effects of multicollinearity on your results will also reduce. This is just because multicollinearity affects what? The standard error. It doesn't affect your t-statistics. It doesn't affect your coefficient just like that, but it affects the standard error. And when this standard error is affected, your results may not be valid for policy formulation. So you can increase the sample size. For instance, if you are covering 1980 to 2020, you can increase the sample size to 1980 to what? 2023, or 1960 to 2023, or 1970 to 2023. So when you increase the sample size, the standard error will reduce, and of course the adverse effect or the negative effects of multicollinearity on your results will also reduce. The fourth method is to remove one of the closely related independent variables. For instance, if the global oil price for Brent and global oil price for WTI, if you notice that they are highly correlated, you can just drop one of the global oil price. Of course, the two measures the same thing, so you can just drop one. Or if you notice that GDP per capita and foreign direct investments are highly correlated, that is, the correlation coefficients exceed 0.8, or when the VIF exceed 10, you can just drop either GDP per capita or foreign direct investment. The last strategy, which I always advise people around me to adopt, is to modify your model. You can introduce the variable in the model one after the other, and there are so many studies that have done something similar. For instance, if you take a look at this study conducted by Oliver and others, Determinants of Trade Flow in the Economic Community of Central African States, these authors, they noticed that the measures of governance, that is institutions, are correlated. So they introduce the variables one after the other. You can see the first variable they introduce here, you can see the second variable they introduce here. So instead of having just one model, you can have two models. If two independent variables are correlated, you can have three models if three independent variables are correlated. So I will always advise you to go for the last strategy, which is to modify your model. All the studies cited in this tutorial are here, so you can just Google it and get the paper. You can go through it, or whenever you are writing a paper and you notice that you need the rule of thumb to back up your explanation, you can cite any of these studies. Now let us go to Eviews so that I can show you how to do multicollinearity test. I've already launched my Eviews and uploaded my data. The first variable here is gross domestic product, which is GDP. The second is inflation. The third is global oil price, Brent. And the fourth is global oil price, WTI. So to conduct multicollinearity test, I can either highlight my dependent variable here is GDP. So I make sure I highlight that first, followed by inflation, followed by oil price first and second. So I go to quick, I click on quick, then move to group statistics, then correlation. So once I click on this, I will have all the variables here. But if I did not highlight the variables here, I won't have them highlighted here. I would, in that case, I will just enter the name of the variable one after the other. For instance, if all the variables here are not highlighted, you just go to quick, group statistics, correlation, then the first variable you type is GDP space inflation space oil price underscore Brent oil price underscore WTI. So once You are through with this, then you click on OK. Here is our results. You can see our GDP, which is the dependent variable, inflation, independent variable, oil price, global oil price, Brent, and global oil price, WTI. If you take a look at the first column, you will notice that all the correlation coefficients are less than 0.8. If you look at it very well, they are less than 0.8. Look at the second column, the correlation coefficients, they are also less than 0.8. But if you look at the third column, you will notice that the relationship, the correlation coefficient for oil, global oil price, WTI, and global oil price, global oil price, Brent, the correlation coefficient is 0.984250, which is greater than what? 0.8. You know 0.8 is our rule of thumb. So in this case, we can conclude that there is a problem of multicollinearity in this model. You understand why? Because the correlation coefficient shows that the value of the oil price Brent and oil price WTI exceed 0.80. So we have confirmed that there is a problem of multicollinearity here based on the results of the correlation matrix that we have before us. Now, let us take a look at the second method, which is variance inflation factor, VIF. So to do that, you first need to run your what? You first need to run your OLS regression. You estimate OLS, then you proceed with the analysis. But take note, when you estimate the OLS, you will also have your R-square. So this process will give us our R-square. It will also give us our what? Our VIF. So let's start with the dependent variable, which is GDP, followed by inflation, the first independent variable, followed by oil price, then followed by oil price WTI. You know, correlation matrix has confirmed that there is a problem of multicollinearity. So we'll check the R square, then we'll also check the VIF. So when this three tests shows that there is a problem of multicollinearity, you have no option than to address it. In fact, if just one indicates, particularly correlation matrix, indicates that there is a problem of multicollinearity, just address it. You understand? So now, I right click on the highlighted variables. I click on open and open as equation. Of course, this is one way you can go to this particular stage. You can also go to quick if you prefer the long cuts. I call this the long cuts. You can go to quick and click on estimate equation. Then you enter the variable one after the other. But that's the long cut, so I don't always use it. I prefer highlight the variables, the dependent variable first, followed by independent variable. Right click, select open as equation, then you have your variables. This is the dependent variable GDP, followed by inflation, the first independent variable, the second, the third, and this C is constant. We want to run least square method. We want to use least square method to estimate this particular model. So we don't have to change anything. You just click on OK. Once you click on OK, you will have this result. Now, if you look at your R square, look at the R square here, you can see the R square debunk or disagree with the results of correlation matrix. It shows that there is no problem of what? Multicollinearity, because it's very low. You understand? But this could be as a result of the numbers of the independent variables we have here. We have just 3 independent variables. If you increase it, you may have issue with your R square. Now to do your VIF, to do to check multicollinearity test, multicollinearity problem with VIF, you now click on View. You know you have already run your OLS. Then you click on View, Coefficient Diagnostic. Then you go down, you will see Variance Inflation Factors. Once you click on this, you will have your results. Look at the centered VIF. You can see that for oil price, Brent and WTI, the VIF far exceed 10. So this also confirms that there is a problem of multicollinearity in this particular model. So now to address this, you can either drop, don't forget the strategies I highlighted here. You can you can just decide to do nothing. You can transform, but in this case, transform doesn't work. So the second strategies will not work. If you increase the sample size in this case, you will still have the same problem. Do you know why? Because Brent and WTI are related. Both measure the price of oil, the global price of oil. So you will still have that particular problem. So the two most relevant strategies here are the last two. Is either you remove one of the variables, you can remove Brent and keep WTI. That is, you use WTI for your estimation. You can also remove WTI and keep Brent. But if you are interested in knowing the sensitivity of your results to the different measures of oil price, you can keep the two. But you will have how many models? You will have two models. That is, you will have two OLS results. So in that case, what you do is, in the first one, we remove oil price WTI and see the impacts on GDP. So I've removed one, you estimate, you copy your result. If you look at it, you can see that, take note, we did not log the variable. We're supposed to log it under normal circumstances, but that's not our focus. So that shouldn't be an issue. If you look at it, we see that oil price here is significant. Yes. And R square is what? It's very low. That's 13%, around 30%. That means other variables we did not include explain over 90% of the variation in GDP. Look at the probability value of the F statistics is significant, so the model is okay. But look at the bouncing, which is very low. So this particular model is generally not okay. But what I'm trying to say is that you can remove WTI and keep this. You run your analysis, you keep the results, then you go back to estimate. You just click estimate and you change this to WTI. Then you also have your results. From here, once you have the result for the two measures of oil price, you can now compare and provide recommendation based on your findings. So that marks the end of this particular video tutorial. Please, if you are just coming across a video for the first time, kindly click on the subscribe button below to subscribe to our channel and turn the notification button or the bell so that you can be notified when we release a new video. I also plead with you that you should share this video with your friends, your colleagues, your family member, anyone that you believe, particularly those in the higher institutions of learning or those in the academy, so that they can also benefit from these free resources. We give shout outs to all our existing subscribers. Thank you for promoting us. May God bless you. Amen.